Today, I'm going to tell you about Markov models. Markov models are named after Andrei Markov, a Russian mathematician who was born in 1856 and died in 1922. Among other things, he studied Markov processes. What are Markov processes? A Markov process is a chain of events that is memoryless. That is, it is the assumption that the next event that will happen depends only on what is happening now, and not what happened previously. A simple example of a Markov process might be a person. We'll call her Romy. Let's say that Romy can travel between 3 different possible places: work, home, and the Eiffel Tower. In this Markov model, each of these 3 locations is called a state. Now what we need is a series of transition probabilities. Transition probabilities tell us which state Romy is likely to travel to, given where she is. Let's assign a set of transition probabilities to each of the states. Every time Romy travels, we call that a transition event. In this model, if Romy is at home, she has a 0.5 chance of going to work, a 0.4 chance of staying at home, and a 0.1 chance of going to the Eiffel Tower. Notice that all of these transition probabilities sum together equal 1. All transition probabilities going out of a state should always sum to 1. How do we choose these numbers? Well, typically, we have to watch a process and count how many times a transition takes place. In our case, we have to watch Romy as she moves around. Let's say that we see Romy leave home 10 times, and she goes to work 5 out of those 10 times. This gives us a probability of 0.5 that if Romy is at home, she will go to work next. Once we have all these statistics, we can construct our Markov model. Typically, our transition probabilities are entered into a transition matrix. Notice that each of the columns of the matrix represents the state Romy came from, and each of the rows represents the state she is going to. Using this matrix, we can compute all sorts of useful quantities. So how do we use it? Well, first we need a starting probability vector that represents what we know about Romy's starting location. Let's say we know with probability 1 that she starts at home. If we multiply our transition matrix by this starting probability vector, then we get a new vector representing our prediction about where Romy will be 1 event in the future. We can apply the transition matrix again to see where Romy will be 2 events in the future. If we keep multiplying these transition matrices, then we can make a prediction where Romy will be at any time in the future, even if that time approaches infinity. Markov models can be a useful and powerful tool. Take it from Romy. Markov models are great.